In our last video, you just saw that if you're given a plan or a topographic map, you can calculate the slope. But can it work the other way? Right? If you know the slope, can you then place contours or draw the contours correctly on a plan? Of course, the answer is yes. So here's how we're going to do it. And I'm following along with figure 9.23 in your textbook. So go ahead and turn the page. And what we've got here is a site. Here's our rectangle site boundaries. Right? And we've got a contour right here for contour 97. And we'd like to have a 5% slope going down in this direction. So the question is, what is this distance between 97 and the next contour 96? Where should we place contour 96 on the plan? The first step to solving this problem is to draw our little diagram. All right, familiar little diagram right here. We've got our triangle. The vertical distance is going to be from 97 down to the next contour. We've already decided that our contour interval is 1, and so that vertical distance is going to be 1 foot. You were given a slope of 5%. That's our goal. That's for grading this particular site. And the question is then, what is the horizontal distance? Here's how you're going to solve this problem. You're going to take this same equation that we've been working with, slope equals v over h, and plug in what we know. We know that the slope is 5%. We were given that goal. We know the vertical distance is 1 foot, and we don't know the horizontal distance. You can solve this equation. All right, first multiply both sides by h. You end up with h times the 5%. All right, I've switched to decimal because it's easier, equals the 1 foot. Right? Divide both sides of the equation by this 5%, and we end up with h, the horizontal distance, equals 1 foot divided by 5. And you can solve that to find that the horizontal distance is 20 feet. What does that mean on our plan? That means if you already have this 97 contour given, then your next contour, all right, the 96, should be 20 feet away. You'll go ahead and measure 20 feet and draw that contour. If we want to continue with an even slope and stay with the same 5%, you would then draw the next contour, all right, again at 20 feet away from there. Let's change it up a little bit and try this exercise again. Here's the same drawing. All right, we've got the same given 97 contour right here. We're still wanting 5%, right? But our map that we're drawing, the contour interval is 2 feet instead of 1, right? How is that going to change things up? Well, first of all, draw your little diagram. All right, we know that your vertical distance is going to equal the contour interval of 2 feet. All right, it's going to go from 95 to 97, or actually the other direction. We know that the slope is 5%. That was given. So what is the horizontal distance? Go ahead and pause the video right here and see if you can do this calculation. And then we'll come back. Okay, are you ready? Here we go. Here is our same equation, slope equals vertical distance over horizontal distance. All right, you plug in what we know, 5% equals 2 feet over h. You can solve this equation, and your horizontal distance is going to be 40 feet. How do these two things compare? Remember our first example, our vertical distance was 1 foot. Our slope was 5%. That didn't change. And therefore, when we drop 1 feet, we come over 20 feet in horizontal distance. Keeping the same slope of 5%, all right, with a contour interval of 2, if we drop 2 feet, All right, we are then moving over horizontally 40 feet.